upload. And the second one will be file embedding. Let's take a closer look at both of these. So if we look at file upload, basically what it is directly uploading files like PDFs, docx, or CSV into an AI chat interface to interact with the content. Why is it the best? Well, basically, it's best for quick, interactive use cases like summarizing, asking questions, or extracting information without coding. So if we focus a bit on the benefits of that,
next slide.
First, next slide, please. First, you'll be able to have a few advantages. So immediate use, you don't need any pre-processing. You can upload a file and start interacting with it right away. And actually, the part that takes the most time is actually the upload time. So just the time that your laptop or your computer is going to take, depending on your internet connection speed, to upload that information to Claude or ChatGPT. Second advantage is the ad hoc flexibility. It is great for temporary one-time queries without needing to store knowledge permanently. If you just want to make sense of a document, there's basically no better way than just take that, drop it into Claude or ChatGPT or Gemini, and then start asking questions without needing to be structured. You don't even need to have a very refined prompt. You could just go and start having a conversation and then figure out as you go what you want to discover about that specific document. Another advantage is that it supports a variety of files. Many AI models allow upload of PDFs, Word documents, spreadsheets, images. You even can provide sometimes presentations. And as it goes, the number of formats just increases. And we see that the most recent models are able to process almost any kind of documents. The last key advantage is the interactive and dynamic aspect of this. Basically, user can directly ask the AI questions and receive real-time insights based on the uploaded documents. So you can really get a lot of value, and you can also make it an iterative process. So you could first start by a first question, and then you can come back, ask another question. And as long as you stay into the conversation, you will basically be able to ask several inquiries about the specific document that you have uploaded. So that's for the first key approach of document upload. Now, obviously, there are some limitations. The first limitation that you can see is the limited memory. Once the session ends, the uploaded file is no longer accessible. So you might be able to go back to the conversation later, but if you are deleting the conversation, or if you want to access the document in another context, then you just can't. This is the second aspect of it. It's session specific. Especially, it is highly difficult. Now it becomes more accessible. Not that the different providers are offering collaborative features inside of ChatGPT and Claude, but basically, the model itself doesn't retain knowledge from the uploaded file for future interactions. So you can't refer to it, and you can't have other people also interact with the file at the same time as you're doing. So it is session specific. Only in that specific conversation you are able to extract information. Then the last part, which was until recently, maybe the biggest limit of this approach, but it's getting removed slowly but surely, is the token and processing limits. So large documents may hit what's called the context window, which is basically the token limitation, or potentially, if they are too heavy, also the size limitations, making it challenging to process extensive content into a single session. If you want to compare 5 very large documents, you might end up just exceeding the size limitations of the context window. Now, the good thing is actually GPT-4, for example, GPT-4o had a context window of 120,000 characters. Now, GPT-01 and 03 have a minimum, and O3 mini have a context window of 200,000 characters, and the newly released GPT-4.1 has 1 million token context window. So actually, you have now the ability to even process extremely large documents inside of one session and one chat inside of ChatGPT with GPT-4.1 as soon as it's going to be available there. It was not the case with Gemini, who already offered 1 million and 2 million, depending on the model, context window. So that gave the ability of processing a larger document. But still, if you want to compare a corpus of documents with, like, let's say, 30 reports, you will still be limited at some point by the token and the processing limits of the model that you're using.
I think we need to somehow, Piv, get like some sort of reference about, because for me in my head, I can't even imagine like what document would have more than 1 million characters. Like how many we need like is the Bible over 1 million, or is there like
Yes, I agree.
like a European report? Because I think that we're getting to a place now where there's not going to be much that you can't do. Like it'll be tough to find a document that's actually larger than that context window.
Yeah, I agree with you. Maybe, if you want to compare to translation of the Bible and see, if the content is the same, but what were the adaptations that were made, that won't be possible. But it is true that with the token limits becoming bigger and bigger, I think that limitation won't stay. And it's a constant evolution of things. We saw in the past that model had to be trained and they had to be also fine-tuned to become better at specific topics. And then as we saw, the new models were just able to achieve the same result with what's called zero-shot prompting. So just without being fine-tuned, without being pre-trained, the new model were just able to reach a certain level of ability that wasn't before.
The one thing I would add on here, and maybe it's something we need to add as well, I would like include it in the token and processing limits. Like even if sometimes you're like, let's say you're attaching a PDF that doesn't necessarily have 1 million characters, you may still hit some limits on file size. So what you have when you're uploading the PDFs to the chat modules, it's also the same as when you do it with ChatGPT. If you're uploading a file that's very image heavy and like big, the model's just going to spit an error and say, hey, look, like that is too, it's not from a context point of view anymore. It's just more from a data processing. So it could be that sometimes you're trying to attach a PDF. I think Claude at the moment is like 30 megabytes or something like that. That could be one limitation that you do run into.
Yeah, but thankfully there's a second technique. But before we go into the second approach to actually work with documents, let's take a look at the first demo on this approach of uploading documents. And in that case, I think we'll do this inside of an automation.
Yes, exactly. So we're going to be doing a demo inside Make, which is an integration platform, automation platform for anyone that hasn't heard about it. Basically, what Make is it is one of the best ways for non-technical business people to actually build out some automations. You can connect to many different tools that you regularly use. And so here I want to give you a demonstration of an automation where if you're receiving invoices as PDFs, how could we have AI automatically extract some information from those PDFs? And eventually what I want to do is I've created like a little spreadsheet here, which is my invoice tracker, where I want to actually collect some key pieces of information from my invoices. And the way this automation works is I have a Google Drive folder here called invoices. And what I want is whenever a new invoice gets dropped into this folder, I want to have an automation run. And what we're going to be using is we're going to be using Anthropic's Claude model and attaching that invoice as a PDF and then extract it and update Google Sheet. So what I might do is I'm actually just going to drop in a PDF into this folder, an invoice. I've got one from Anthropic. So let me just drop that into the invoices folder. And the automation, I'll go through it step by step in a second, but I can just already start running this one. What it's going to do is it triggers, and imagine like you could run this every morning at 8 a.m. For instance, it checks, were there any new invoices added to this folder? If it does, it downloads the file so that in our automation, we can use it. And then we basically attach it to the Claude prompt. And for anyone that doesn't know, Claude is basically a model from Anthropic, a competitor to ChatGPT from OpenAI. And it's one we like to use in a lot of our automations. So how have I set this one up? Basically, when you go and prompt Claude via a workflow, what I'm able to do, and I can even just create a new message here. So whenever I want to add a message, I can choose what type of message do I want to send. Do I want to send a text message? And this is what I have here is a typical prompt. Or what I can also do is attach an image or a PDF document. And in my case, what is exactly what I've done up here, I've attached the PDF document. So you can think of this exactly the same way as if you go to ChatGPT and attach the invoice and then ask it this prompt saying, hey, you're an assistant specialized in extracting and analyzing information from an invoice PDF. This is the information that I want you to extract. ChatGPT would have no issue doing this. Claude would have no issue doing this. What's great when you do this in an automation is you don't need to do this manually. You can have something running, like as I said, you trigger this at 8 a.m. every morning. Your colleagues can just be adding invoices to this folder. And let's see how it did. I can check out the text response. So what I've asked it to do is give me a little bit of overview of the extraction process. This is more just a technique that whenever you get a model to explain its reasoning step by step, it tends to give you better results. But what I have at the bottom here, which is very important, is I've just got what's known as a JSON object, which is a certain way of structuring data where I've only got the key information that I need access to. And then within a couple of steps in Make, we can get to something which is very, very dynamic and scalable, where I've taken this object and found each of those items separately, which is what we can then actually map to our Google Sheet step, where I've said, hey, I want you to put the sender in the sender column, the sender address, the invoice number. And if we take a look at our Google Sheet, we saw that that row has now been added with all of the information exactly correct. So these models are very, very good at doing this sort of basic extraction. And what this is great now is it's like, no matter if your PDFs have in different formats, because what the large language model is doing, it's not looking at a specific area in the PDF, it's really understanding the context of what is in the invoice. In some cases, you might have the sender in the top left. In other cases, you might have it in the top right, but it will understand the contents of that document and be able to upload this. So for instance, here I had another dummy PDF. And if I open this one up, we can see that it's like, this one looks totally different to the invoice from Anthropic that I just uploaded. If I open the one from Anthropic, you can see these two invoices look totally different, but Claude has no issue with getting the exact right information. Any questions on this one?
So far, we don't have any question in the chat, Jan. I think right there, what you just showed is, I think, the most important and the most powerful part. Because beforehand, it was kind of possible with OCR, like it was a bit costly, but it was feasible to train or to use an OCR, which was a bit pre-trained and which was able to extract the specific information from different parts of documents. It was getting way more difficult if you had documents of different types or different structure. And what's really interesting here is potentially, especially if you craft the prompt a bit better or a bit more in a bit more details, you could potentially provide different type of document and ask the LLM to always return you the same set of information, meaning you could provide or you could extract information from an invoice, but also a CSV file, a receipt. Like you could try to potentially have different inputs and all return then an Excel output. And if you think of a lot of businesses, like for example the financial industries or insurance domain, so there's a lot of people which are actually handling a lot of documents on behalf of customers, and they're receiving different documents from different providers that might be structured in different ways. Having the ability of just ingesting all of these documents into a unified database is extremely powerful, and this is something that required human manual labor until now. So very exciting on this one.
Yeah,
we have a question from Nuno. Is there any way to do it without the JSON step? It has the output to be in that way already.
Yeah. So the important thing here in like Make or Zapier or any automation platform that you're using is to understand that whenever you get a response from a certain tool, you can basically use that response and map it in future steps, right? And so that's why it's very important here that the way I've basically formatted this is that every data point is here separated. The one thing at the moment that you cannot do, like most large language models, even when you use them via API, will just give you one long text. And then what you'll need to do is some sort of manipulation of that afterwards. So it's very important that you instruct it how it should format the data. So for instance, here I've said, I always want you to give me this final JSON with between this invoice analysis tags. And that way I know exactly which part of this text response I can extract. It is a bit of engineering in a sense, even though it's no code, it is still a bit of engineering. Now with ChatGPT, they do have an option where you can actually determine, and already here, instead of just having a text response, you could already have an output with the different data points that you want, but it really is depending on the LLM provider. But that's why we're big believers of business people understanding how to do this basic manipulation, so that no matter, even if your response is just in a big text string, you'll know how to get the exact data points out. But I hope this is something that also the LLMs will actually offer. It would be great here if I could have a section where I can say like determined outputs that I want to have, and it will actually give me those separated in the API response.
Yeah. We have two questions on this, and first, maybe let's first show, because it's quick, how you configure the JSON step.
So this one here. So the most important part is actually this regex step, because and this is a very specific thing of Anthropic. I can even share a article afterwards. What they recommend, they really like using what are known as these XML tags to separate different parts of the response. So what I've given in my prompt, I said, first, like, list out your extraction process. Tell me the thinking and the different steps. And I told it to answer me that. If I take a look at the prompt here, I basically tell it, after your, where is it here? Exactly,
Maybe,
after
Jan,
your
because
analysis.
that will,
Yeah.
sorry, Jan, that will go into the question that we had before from Jessie. She actually was asking about, more like how you written the extraction process part of the prompt just to ensure the accuracy of the JSON. So maybe can you pop out a bit, enlarge a bit and zoom a bit on your make so we can actually take some time to go through the prompt. I think it's going to be useful for a lot of people.
Awesome. So let me see if that's a little bit better on the prompt. So the first thing is just basically plain language, saying that you're an AI assistant specialized in extracting and analyzing information. And then here I just give a bullet list of what information I want to extract, right? Then afterwards, I need to give some specific information about the formats of the different data points, because for instance, we're dealing with dates, we're dealing with numbers, we're dealing with text. So for instance, I'm saying, I want you to convert all dates into this date format, because what you'll see is in some invoices, you might have dates written. Let's have a look here. This date is written like this, actually written here as text in German, whereas the other invoice is written, let's have a look, with just like the month and then the number. So in invoices, you're going to get all different types of formats of dates. So I've just told my LLM, hey, no matter what format the date is in on the invoice, when it comes to data, I want it structured a certain way. And then what I've told it here, and the best way to get an LLM to give you a certain format of a JSON is by giving it an example. And what I've done here is given an example of how the response should be. Very importantly, I haven't put any values in here, because what I don't want is sometimes when you put values in the example, if it doesn't find that information, it will just put what you put in your example. So I did this before where I actually put a total amount of 100. And then in the results I was getting from the AI, it was always putting 100, even though it wasn't actually extracting it. So this was a good way that I found, is give an example of the keys in your JSON, but not necessarily the values, if that makes sense. And then here, I've actually given an example, but without putting specific, like, for instance, I'm not putting a company name. I'm just telling it where it should put the company name. Does that sort of answer the question, Viv, you think?
Yes. So I think if you summarize, the first thing you did is you explain in plain English the different data point that you want to extract from the document. So you list all the data points. In the second part, then you explain again in plain English the format in which you want the data point to be outputted. Like for the date, the format for the date, potentially if there's a number, the format of the number, etc. And then in the third part, you provided an example of the JSON structure, but this time empty. And then you even had the fourth with a mock information, so not from a real company, but just a fake information and with some.
It's more reinforcing the format here, I would say. What it's doing is reinforcing the format that I explained earlier.
Okay, and then that will ensure, and also to finalize and to make sure that you have this and that you are able to then parse that JSON. You specifically ask Anthropic, which to be honest, it tends to do very often, to return that inside of specific XML tags, so that you know that you will have an XML that will contain invoice analysis, and that is basically the part where the JSON is going to be outputted.
Exactly. And I think there's somewhere else, I can't look at the prompt right now, but there's somewhere on where I also ask it to explain its analysis, and that's why it gives me those two different XMLs. And then what I can do easily here is in this regex part, it will only give me the JSON, which is in that invoice analysis tags. And then finally, I can actually map it. So it is a few different steps, but it is one big way that you do need to do this extra work, because otherwise you'll just end up with a text. So it is the way that you can actually convert this long text response into a thing that you can actually map to specific data points. And when it comes to documents, I think that's a very important aspect.
Yeah, super interesting.
We actually have a very similar case, but I just wanted to show you because I know people are using a different model, so I can go quicker on this one. And that is an example with Gemini. And what we're going to cover here is extracting data from very, very messy spreadsheets. I don't know, Piv, if there's any other intro you want to give on this one.
No, but I think that's that's a good way. Like, I think what we had, we have unstructured data into documents. We want to just transform that into structured data into database. I think it's also a good example to just like take a document, which is even like a spreadsheet, which is in itself can be, just document that contain a lot of information.
Yeah. And so what I've done, it's a bit of a ridiculous example here, but it's one that we see far too often. So imagine in a use case where 9x, what we want to do is we want to have partnerships with a lot
Can you
of
zoom
different.
a bit, Jan? Maybe
Yeah,
can you zoom
yeah,
a little bit into your Google Sheet?
yeah.
Yeah.
Let's do it.
Thanks.
So we want to have partnerships with a lot of different automation agencies, and each of those partners are going to give us a spreadsheet of their agency details. So for instance, here I've got one tab with company details, and for any spreadsheet enthusiasts out there, I apologize in advance because this is going to be one of the worst spreadsheets you're ever going to see, but we actually see real scenarios of this. So here we have the company data on one point. You could say it's almost semi-structured. My OCD is like kicking off a little bit that the first row here is empty. But then afterwards, what we have is we actually have a different tab for each contact person. So this agency that we might be working with has some contact people. And in each tab, they've given us the contact details. So Eliza filled out her contact details in this tab. Then we had Rajiv. And you can see even between the tabs, they have totally different structure. Eliza's just written out her information, whereas Rajiv, at least he's put like name, title, email, phone. And then we see there's another sheet here where actually Marcus has put in his details, hasn't even bothered naming the sheet. But here we have it a little bit different, where actually all the contact details are in a different row. And imagine, of course, if you just wanted to extract information out of this one, it would be pretty simple. But imagine if we have 100 partners that have given us spreadsheets like this, where I don't want to go through all of those spreadsheets. I just know there's important information in there, and I want to be able to extract it. So what we've done, and let me just find the scenario.
What you're looking for the scenario. For sure, this is not the way we would have structured a spreadsheet. And if you know about, databases and how to structure data, you would not do that yourself. But think about all the organization where data started to be collected on cloud documents like, Google Sheets or Excel files before everybody was more, versed into how to structure data and how to structure databases. And actually, that was the way, originally when the first cloud document appeared, it was a good way of sharing information. And, enforcing a data structure was not relevant at the time because there was no idea of eventually getting that information into a database. So you might just be in an organization that has so much information already living, it's just unstructured. And I think that's one of the great use cases of AI is it's a marvelous way of going and getting and accessing existing unstructured data and making it structured to be able to be accessed from other more, programmatic applications or applicative solutions.
Yeah, definitely. And so what I've done here is a very similar one. So I basically have a Google spreadsheet. And again, I've got an automation in Make that's triggered when the spreadsheets are added to a certain folder. So imagine if you had 100 of these spreadsheets that all look so horrendous, we could just chuck them all in a folder. And what this automation will do is it'll go through one by one and do some processing. And what I wanted to showcase here in Gemini is two things. First of all, Gemini is something that more and more businesses will have access to now that Google have basically made this widely available. So maybe even if you don't have access to Claude and you can attach PDFs via API or via automations, Gemini is a great option. Theirs is a little bit different. What I need to do, so you'll see the first two steps are identical to the case with Anthropic. However, here with Anthropic, what I could do is I could actually attach the file directly in my prompt step. With Gemini, it's a little bit different. What I first need to do is actually upload the file to Gemini. So here I've got one make action that just uploads the file that we just downloaded from Google Drive, which is the spreadsheet that I have set up. And then finally in the prompt step, again, I'll make this one a little bit bigger and zoom in a little bit for you, is the first thing I do in my message is I pass the file that I've just uploaded to Gemini. And this is exactly how basically Gemini needs this. You have to upload the file, they'll give you a link, and then you attach that with your prompt. And then the prompt is very, very simple. So here I've basically said you're an assistant tasked with extracting and structuring information from a Google Sheet. The sheet contains details about a single partner company, including general information and contact details for several professionals. Here I've given it some objectives about what data it should try and extract for the company, then also what data it should extract for individuals, and again, giving it a final output in the JSON that I want. So let's see what happens when I run this one, and then we can take a look at the results. So what I need to do, all this one, I'm not actually saving this anywhere. I just wanted to demonstrate the final JSON that will create. So I've already actually added this sheet to that folder, so I can just run this one. And right now the file was just uploaded to Gemini. Now Gemini is basically going to read that spreadsheet. And the one thing that I mentioned while I've uploaded this, in this download a file step, what I actually needed to do was convert the spreadsheet, the Excel file or the spreadsheet file, to a PDF so that then Gemini can read it. So for some reason, I hope they enable it soon, Gemini wasn't able to just read directly the Google Sheet. That would make a lot of sense, but I had to convert it to a PDF and then gave that to Gemini. And so if we have a look at Gemini's response, we can see what they've done. They've given me the JSON here. And now we have all of that like crazy chaotic data where we have like the company details on one tab, Eliza's information on one, Rajiv's on another, and Marcus's on another. And it was able to actually interpret all of that and gives me a very well-structured JSON. Now, people that are not familiar with JSON might be a little bit put off by this, but I can show you once I've actually passed this one, how very useful it is. So I'll zoom in a little bit here. So what we have is the company information cleanly sorted. And then for each contact person, we have them in what's known as an array. And then I can get exactly for each person their contact details. And you notice there was actually 4, Diana Washington. She was mentioned on the first part of the contacts here, but doesn't have a separate tab. So what it did is just said, hey, there's another contact person, but we don't have any other information about them. And this is like going from like crazy unstructured data to very, very well structured data just by using automation. And all of these can then be mapped into a system or cleaned up. And the most important thing, this can be done at scale for many of those messy spreadsheets.
You can literally turn a bunch of spreadsheets lying around somewhere into a structured database with several objects, company, contacts. That's pretty cool.
Yeah, and Gemini is super fast at this, I have to say as well.
Yeah, it's
awesome.
You know, that's the good thing. You know, it's a free product now for all the Google users. Last week, while everybody was generating Ghibli Studio style images, it was actually for 1 week the best, the most performance model on the market. And a week later, there was like a new release from Anthropic, new release from OpenAI, and then Gemini went back to the 3rd place. But at least, you know, it is powerful, it is useful, it is very good at doing some things, and it's available for most Google business users. So pretty exciting.
Very
awesome.
exciting.
Now let's take a
Awesome.
look. We have 12 more minutes to go. I just want to make sure that we touch a bit on the second approach that is possible, which is file embedding. So what's file embedding? Basically, it's about transforming a document content into what's called vector embedding to enable semantic search and querying. So how it works is basically that you take a file, the file content is processed using embedding models, and then the embeddings are stored in a vector database. And finally, you can run queries that are matched with the document content using what's called similarity search. So for this, we just need to take a little pause and explain basically how LLMs work. I'm going to make a lot of shortcuts, but basically, fundamentally, one of the processes that is used in an LLM is to take any token, any word, and then transforming them in what's called a vector. And why would we say a vector? It's because when you say that the model has, let's say, 1 billion parameters, where basically it is just taking the whole universe of meaning and putting that into a multi-dimensional space. And every single parameter is basically an entity, or it's a scale of meaning. And basically, if you let's say you have 1 billion parameter in your embedding models, it means that every single word or every single token is going to be transformed into a vector. So it's a long set of 1 billion numbers, which is basically indicating on all of these axes what's the position that represents the meaning of a specific token. So eventually, that's how LLMs work, and that's how they're able to process meaning and what we call semantic meaning. They basically take a token or take a sentence and they transform it into a big vector, and then they are able to perform a mathematical calculation, which is basically calculating the distance between the 2 vectors. You take the 2 vectors, and then you're able to say, okay, are these 2 vectors close or not? And based on this calculation, you are able to know what has meaning. And then eventually, that's what happens when you do file embedding. You take a big bunch of text, or you have a document, you put it into the LLM. The LLM stores that document, like it takes time, it processes it, and it uses the models, the embedding model is used to transform the text into meaning, into vectors. And then eventually you can run queries against this. And when we say it's basically similarity search, it means that basically you are not looking for information based on keywords like you are doing when you're using, for example, Google or any indexing which was reliant on the words, but you're actually searching based on meaning. So basically you are able to retrieve all the information based on what it means and not how it's written. And this is best for scalable, efficient querying of large static datasets or knowledge bases. Now, there are some limitations, and we'll see just afterwards. So if we go to the next slide, basically, Jan, we can see the main advantages of file embedding is that it is persistent knowledge. Whenever you embed a file into a vector database, you can then attach that vector database to a model. That's what you do, for example, in a ChatGPT when you use the assistant. You can create a vector storage or a vector database, and then you attach an assistant to it. And basically, as soon as it's attached to it, the assistant is using that knowledge as if this was its training knowledge. So it's immediately accessible. And it can be, of course, yeah.
Yeah, on this one, would it be like a fair analogy to say the difference between like file uploading and embedding in this case of like persistent knowledge? Like if someone asks me a question, either I know that already in my brain and I can just give an answer, or of like which is more file embedding. Whereas when it comes to file uploading, someone would more give me a piece of paper and ask me the question, and the answer is on the piece of paper, and I need to go and look at it.
Yeah, exactly. Basically, when you embed, you make the document part of the knowledge of the model that you're using, or the instance of the model.
So it's like saying that you remember, I remember my birthday. I don't need to go and look it up. Someone asked me, I've got that embedded in my knowledge, and I can just give the answer straight away.
Exactly. And that brings to the second advantage, which is basically it supports large-scale knowledge retrieval. The embedding enables AI to search across large data sets efficiently, and then that improves the response accuracy. And it also means that even if you want to actually work with extremely large documents or a big set of documents, the amount of data that you can provide as embedding, which will have a cost, of course, but is not limited by the context window. So basically, you are just extending the capabilities of custom knowledge that you want to provide to your model. The third advantage is that it's optimized for semantic search. So basically, the way the data is stored makes it easy for the AI to retrieve the relevant information across various documents using vector-based similarity search. So basically, the model is even able to look for information of similar meaning throughout the different documents. And this is one thing that is way easier to do when you are embedding your document, because then you can start manipulating information from all the different documents and in a more efficient manner. And finally, the document, that's the most important part. Once it's embedded, the document doesn't count to the context window anymore. So then you can potentially, let's say, you could submit a very large amount of document, let's say, hundreds of books, and then you can write a master thesis on these books, and you could take basically all the books are part of the embedding, and then you upload your document, you upload your research paper, you upload your thesis, and then you can start having discussion with your AI on the specific document that you have uploaded, taking into consideration all the documents which are part of the knowledge.
And Piv, on this one, obviously there's no token limit, so it makes it very efficient when it comes to because obviously like people are familiar now a little bit with when they are leveraging large language models via integrations or APIs, that you basically have to pay based on the amount of tokens you consume. However, what we've seen from the platforms that offer this knowledge embedding, obviously because they don't count towards token limits, the one thing what they tend to do is basically charge you for how much knowledge you have embedded, right? And the longer it stays there. So it's a different model. It's just something to take into consideration.
Yeah, you are paying per days or per instance of time for which the like a gigabyte of a document is embedded. So it's a different model.
And then Nuno has a question on like saying that this is a very interesting option, and whether we use it for ourselves for which specific use cases, and whether it can be leveraged inside like Zapier, Lindy, or Make. I think we'll save that one to the end, because we do have a slide on this of like the different use cases, and we actually have a little demo as well.
Yeah. I'm not sure if we have enough time for the demo though. But
okay. Then we skip that and we go through to the end.
Exactly. So if we go into if we look quickly at the limitation. So the biggest limitation is there's no immediate interaction. unlike a file upload, embedding typically requires some what's called pre-processing. So if you have a small document, you won't feel it that much, but it takes basically time. And it takes more time than what it takes to upload the file, because you upload the file and then basically it takes the time for this embedding process to happen. So you can't just put the file and then start working with it in real time. It takes a bit of time. You also, if you add a new document, well, you need to make sure that you update, that you update the knowledge base, because there is the processing which is involved. As then we were mentioning before, there are some potential costs, and hosting and querying an embedded knowledge base will involve additional costs. And then it has a limited context per query. Even with embedding, AI models still have token limitations and may not retrieve all necessary information in one response, because basically they make the query. So the whole document is not part of the context window. Then the model is making a query, and the result of that query, so what it gets, so it's looking for something, and then the response of its searches then is injected into the context window. So you can't just take the whole document as context when you give the answer, when the AI is giving the answer. It is actually taking your question, making a semantic search against which part of the different documents are providing information to that, but it will still, when it responds, it doesn't take into consideration all the document, but just the part of the document that is actually, from a semantic and from a meaning point of view, relevant for the question you ask. It's just to be technically correct. You don't answer with the whole document. You answer with the part of the document which is relevant, and there's a search which is happening there.
Now, while we we probably won't have time for this full demo on Dante AI, but maybe what I can quickly showcase, if anyone sounds interesting with file embedding, the easiest, the simplest way to test out file embedding is if I just go here to a new screen. If you have a ChatGPT account, you can create what is known as a custom GPT. And here you'll see in the knowledge, upload files. And when you upload files to your custom GPT, so for instance, companies have been doing this with maybe their terms and conditions, or you have a long list of FAQs, or you have a long list of prices. If you're a SaaS company, you can create a custom GPT for your internal team, upload the knowledge, so either as a PDF or text, and then give some instructions to how it should handle it. But that is file embedding. When you're uploading files to a custom GPT, it's embedding, and it's actually using that as knowledge and not file upload. Is that right, Piv?
Yeah. All right.
So anything else?
So just to give an overview, so we have the example of the custom GPT. We showed Dante AI is just because I think it's it has some free version, and you can have for $5 a month or $10 a month. It's the simplest way to just take a document, you put it, and basically you generate a chatbot that only answers questions based on the document. You can also give it the ability of going on the internet or using some pre-training content, but it's just this one. I just put it there because it was very useful, very easy to use. To give a first result, and it can be a gimmick, but if you want a small marketing gimmick on your website, that's something that you could use, and it has some more advanced features. Obviously, we use custom GPTs. You can also create gems in Gemini, or you can now create projects in Claude. And if you want to use more advanced workflows, Relevance AI is actually pretty good with knowledge. You can also use knowledge in Lindy, but it's in Lindy you can use some external document as knowledge, while in Relevance you can ingest some it comes with a knowledge base that you can work with. So when we need to work with the knowledge, we tend to use Relevance for this specific case of building.
And Relevance, for anyone out there, is an AI agent builder. So if you're building agents, Relevance it's basically you build an agent, and that agent has access to this embedded knowledge.
Yeah, I mean, Lindy also offers that, but the way Relevance makes it, for me, it's a bit more natural to use. So if you go to the next slide, basically, we're also covering what exactly how do you decide on the right method? So I think that basically, if we make it very simple, between file upload and file embedding, I think that you would upload a file if you need to either ask several questions about you want to ask the same question about many documents. You want to always run the same action on a document, and then that's when you would use file upload, because you don't need all of these documents to be taken into consideration. On the flip side, if you want many different people to ask either a different question or the same question, but potentially different question in different instances, so in different conversation, about the same document or subset of documents. The typical example is like Q&A, chatbot, a legal chatbot, an internal wiki chatbot. That's why you would use embedding.
And I think the example of the example of the invoice extraction is exactly that. When like with invoices, we're asking the same question for every invoice. I want to know the sender. Exactly. I want to know the amount. I want to know the currency. I want to know the due date. They're the same questions, but every invoice is different. It's many, many documents. So it doesn't make sense for like the AI to actually learn and embed into its memory the context of that invoice, because we just want it to read it, extract it, and move on, right? Whereas when it comes to like a website Q&A, you want it to actually remember that and be embedded in its knowledge. So this is just a quick guide to help you decide on the right method for the right use case. But Piv, I think we have one little, like, let's say, asterisk on that one.
Yeah. So basically, I think like this part is from like it's an interesting and I think we can share the link to this to the article. But it's basically from Anthropic. It's good that to be reminded that sometimes the simplest solution is the best, and in some cases you just copy paste what you have in your document into your prompt, and that's going to yield the best result. That's going to be the fastest. So you don't have to necessarily go with the most advanced technique to have the best result. I think to come back on the question from Nuno, one very interesting use case which we haven't done yet, but we will 100% do very soon on the usage of file embedding. I think it's important to understand when I was referring to file embedding and to semantic search and this embedding process, it doesn't have to be only for text embedding. Embedding also works with images. And now that we have documents, that you have models that are becoming multimodal, meaning that they can actually take an image, take a text, and both of them can be represented into a multimodal embedding or a multimodal way of representing information. So basically, they have different encoder and decoder that takes different inputs, but they get all embedded into the same sum of parameters, and then you can output image and text. Well, now that we see the capability, especially from the last update from 4.0 with their image generation, you could really think about taking all of your brand identity and creating I don't know if it's going to be a custom GPT or a GPT AI, AI assistant that will have your brand identity and a lot of examples of what, a good way of generating, visuals, illustrations. If you can have potentially think of your custom emojis or custom icons that you use in your presentation, and then use that custom GPT or use that, that AI solution that is using embedding to generate on-brand visual that come and that can expand what you're currently using. If you need some new way of Peronsky, a new little drawing to express a new meaning when I'm creating a new slide. That's for me one of the things that I'm the most exciting about, because this is something that I personally can't do. Like, it's just not possible, and you don't want to, like, very often when you try to just put an image, you say, okay, can you adjust the image? It's not exactly on brand. If you want to give the idea of on brand, well, you can just provide 25 pictures, including your branding guide, and then it's going to be on brand. And this is typically a good example where actually for me, file embedding will make a lot of sense.
Yeah, totally.
That's pretty much what we wanted to cover today. We didn't have time for the last demo, sorry, but we're limited on time. Do we have any other questions? Anything that we haven't covered and that you would like us to answer regarding using documents inside of AI applications?
And I think on that one as well, what I'm going to do, I'm going to end the stream. So for those of you watching on YouTube, yeah, I'm ending the stream. But for those in the live session, we can definitely answer a few more questions.
See you, YouTube.
All right. Any more questions?